So we'll go ahead and wrap pieces up and just work through a couple more examples. Inverse sine of theta equals negative 0.766. What do we know? Sine is negative in quadrant 3, quadrant 4. Find your reference angle. Theta r equals inverse sine 0.766. When we run through that through the calculator, we're going to get 50 degrees. We need to live in quadrant 3. Who has a reference angle of 50 degrees in quadrant 3? 180 plus 50 equals 230 degrees. In quadrant 4, what do we have? 360 minus 50 equals 310 degrees. Continuing, cosine of theta equals negative 0.8192. Cosine's negative in quadrant 2, quadrant 3. Get your reference angle. Theta r equals inverse cosine 0.8192. Calculator will tell us that that's going to give us 35 degrees. We're very close to it when we round. Who has a reference angle of 35 degrees in quadrant 2? And for that matter in quadrant 3. 180 minus 35 equals 145 degrees. 180 plus 35 equals 215 degrees. Two more problems to go. Tangent of theta equals 0.4773. Quadrant 1, quadrant 3. That's where tangent's positive from all students take calculus. Get your reference angle, which by the way is going to happen to be one of our final answers. Inverse tan of 0.4773. Let me run that one through my calculator real quick, see what I get. I come back with 25.5 degrees. And we'll keep that. It's not a great way to round that either way. So quadrant 1, my answer is 25.5 degrees. Quadrant 3, who has 25.5 degrees as their reference angle? 180 plus 25.5, 205.5 degrees. One final problem to do. Tangent of theta equals negative 1.3764. Quadrants 2 and 4. Reference angle, inverse tan of 1.3764 equals, we're going to come back with right around 54 degrees. Who has 54 degree reference angle in quadrant 2? 180 minus 54 equals 126 degrees. 180 plus 54 equals 234 degrees. Quadrant 3. So bottom line, follow the suggested technique. Take a look at your input value. Determine, by all students take calculus, what quadrant you need to pull angles from. Take that positive input value always and run it through your inverse sine, cosine, or tangent function to get a quadrant 1 reference angle. From there, apply your reference angle to the quadrants you identified that work for your particular statement. Hey, if you always have a quadrant 1 answer, your reference angle is already going to be part of your solution. Just apply your formulas to handle any cases where you need answers coming out of quadrant 2, quadrant 3, or quadrant 4. And that's the bottom line process that you'll work through with these types of problems. Be good with the technique that you see suggested up here. Our last piece of this lesson is going to focus on some word problems. Here's our first one. We're going to now solve a triangle. We're given sides. We don't know what the angles are. Fortunately, it's a right triangle, so that's going to help us. I know I got 90 degrees here. I'm going to call this triangle A, B, C. And just the way I built it, I'm going to go ahead and put my 25 here. I'll put my 17 here. This is my little c, which happens to be the hypotenuse. I can build that very, very quickly. I'm going to want to find these two angles, angle A and angle B. I'm going to find them in degrees mode. So let's do a little work first. Pythagorean theorem would tell us that c squared equals 17 squared plus 25 squared. You're going to find out that c squared equals 914 and c equals the square root of 914. Sorry for being left-handed. About 30.2. I got all three sides. Now, all I need to do is, tell you what, I'm going to try to find angle A first. And what I know for angle A, 25 is opposite, 17 is adjacent, 30.2 is the hypotenuse. I'm going to use the tangent function. The tangent of angle A equals 25 over 17. That tells me that angle A is equal to what? The inverse tangent of 25 over 17. Trig, angle equal value. Inverse trig, value equals angle. And what's my calculator going to tell us? It's going to give me an angle right around 55.8 degrees. Now, let's just stay with tangent. I could also say that the tangent of angle B equals 17 over 25. Inverse tangent of 17 over 25 equals angle B, and I'll find out that that's going to be right around 34.2. 55.8, 34.2 adds up to 90. 90 plus 90, 180. I have three sides. I have 1, 2, 3 angles built. Okay. Here's a nice question. Find the angle of elevation. Before, with these tower and shadow problems, we gave you the angle of elevation. We asked you to figure out maybe how tall is the tower or how long is the shadow. Well, here comes my tower that I know is 553 meters tall. I know what? The sun is sitting way up here. It creates a shadow. And I know this shadow runs how far? 1,100 meters. What's the angle of elevation from the ground up to the tower and then obviously up to the sun? What's this angle? Let's call it A, angle A. What do I know? I know that the tangent of angle A is equal to opposite over adjacent. 553 over 1,100. What's that help me do? Angle A must equal the inverse tangent of 553 over 1,100. And when I run that through my calculator, inverse tangent 553 over 1,100, I get angle A is 28 point, let's just go a couple decimal points this time, 28.94 degrees. Again, bottom line, set up, use your right triangles, use your SOHCAHTOAs, use your inverse trig functions. You're good to go with these. One more problem. Photographer is taking pictures of a 150-foot tall roller coaster. A camera is set up so the lens is 3 feet above the ground. So here's my nice little camera on a tripod. It's 3 feet above the ground. Okay. From this tripod, I look up my first example. I'm going to build two triangles just to make it a little bit easier. I'm going to look up at the top of a roller coaster, which is 150 feet high. Remember that I am what? My camera is 3 feet above the ground. What's that tell me? This height is 147 feet. How far away is the camera from the bottom of the roller coaster? 300 feet. So I have a nice little triangle to work with. The key things that I care about are the 300 and the 147. Here's my triangle. I'm going to really highlight it. Notice that my triangle sits 3 feet above the ground. Now my second triangle, again, tripod, still 3 feet above the ground. It's going to now be aimed what? I'm going to be 200 feet away from the roller coaster, and I'm going to be aiming at a spot that is what? 2/3 of the way to the top. Well, 2/3 of 150 feet is 100. There's the top of the coaster, so to speak, that I'm looking at now, or the 200-foot mark, 100-foot mark of the coaster, excuse me. I know I'm 3 feet in the air already. This little triangle must be a height of 97. Remember, 3 feet above the ground, 100 feet total, 2/3 of 150, 3 plus 97 would equal 100 feet. Which angle is bigger? This one in red or this one in blue? Well, let's call this angle A. Let's call this angle B. What can I say? I can say that the tangent of angle A equals 147 over 300. I can say that angle A equals inverse tangent of 147 over 300. And I'm going to get an answer of 26.1 degrees. That's the angle of elevation that the camera's looking at when it's looking at the top of the coaster. Over here, 200 feet away, 97 feet up, that's what this angle is working with. I know that the tangent of angle B is equal to 97 over 200. I know that angle B is equal to the inverse tangent of 97 over 200. And when I run that through my calculator, I get 25.8 degrees. For which picture is her camera aimed at a steeper angle? 26.1 is bigger than 25.8. There's the steeper angle. Steeper angle comes in this view, 300 feet away, looking at the top of the coaster. So word problems, build your triangles. In most instances, you're going to be building a right triangle. You'll be able to use your SOHCAHTOA principles, and this time you're going to use your SOHCAHTOA principles and the inverse trig functions to find an angle. This concludes section 5.4.